Let's get started because we got quite some ground to cover. A warm welcome from my side, from our side.
Yeah.
This is me, Juergen, and my dear friend Josh here up on stage for you.
Hi.
So we are here today
To take a selfie. Now,
to take the mandatory
Right.
Josh Long selfie. Sorry,
so
that has to be.
what we're going to do, there's a lot of you. We're going to take a selfie, and I want you to all get into a group huddle.
Yeah.
Or not. Fine. Okay, don't do that. Don't
No,
do
just
that.
keep sitting. We're going to take
okay.
a selfie.
Just sit
a
still.
second.
Just pretend like you're happy.
Yeah.
Wait. Okay, can we turn on the lights, friends? Lights, camera, audience. Oh, AV people. Whatever. Okay.
Then we do it then.
We'll Photoshop you all in. There's 1,000 people. Don't look around. There's 1 million people. Pretend like you're happy. 1, 2, 3. Open source.
Open source. One more.
Huh? That's so many.
That,
Good
that
stuff.
that has to be good enough. Thanks for the lights on.
Yes.
Anyway, okay. So for today's session, we are going to introduce you to our reactive programming story, not only in Spring 5 itself, in Spring Framework 5, which may be your most immediate reference. We're doing it more from the ground up. You're going to see a little bit of a reactive Mongo repository. You're going to see quite a bit of Reactor API usage, and a little bit of Spring WebFlux in Spring Framework 5 itself. The motivation for reactive programming in general is worth a talk on its own, but I'm going to give you a brief introduction. We decided a number of years ago to focus on a Spring-style reactive programming model, and it's been a long time coming, finally released now, out of the R&D stages right into Spring Framework 5.0 proper. So the Spring Framework 5.0 release, GA planned for late July, is going to include the entire reactive programming story. However, we are not just starting from scratch. We're actually building on a project called Reactor, currently approaching its 3.1 release. Project Reactor is a key piece in the puzzle. It's our core reactive engine. It's a separate project, not Spring branded, because it's broader in terms of its field of use, but it is the foundation of everything we are doing in the reactive space in Springland. So Project Reactor essentially is a reactive kernel along the lines of RxJava. So just maybe a quick opportunity. Who's familiar with RxJava? At least a little bit familiar with it. All right. Well, that's great because you're going to find yourselves comfortable with Reactor's API as well. Reactor and RxJava are very much aligned in terms of their terminology, in terms of their operators, their signatures. However, Reactor is a more focused, tighter arrangement. It's Java 8 based, can make use of Java util function interfaces out of the box. It's more server oriented, and it's distilled down to 2 entry-level types called Flux and Mono. So just in case you wonder what Flux and Mono means, it's going to reappear many times in this talk. Those are the 2 essential Reactor API types, comparable to RxJava's observable and single, or flowable, and maybe. They basically represent an entry point into composing a reactive processing pipeline with many convenience operators and certain semantics attached. Flux representing a hot stream of elements, and Mono representing a single element or none. Both reactively enabled, both implemented as reactive streams publishers. So what's reactive streams? Reactive streams is an industry initiative, several collaborators, both from Lightband, Akka, RxJava, and Project Reactor on Pivotal's end, where there is a consensus on the underlying mechanism, your choice of infrastructure interacting with each other at the lowest level through the reactive streams mechanism. Reactive streams is a very straightforward specification. It's basically just a bunch of interfaces, a publisher type, a subscriber type, agreeing on a subscription with a very straightforward minimal mechanism for implementing a degree of flow control at runtime. Reactive streams is essentially something you're not working with directly, really. But the pieces of infrastructure that you're using when composing a reactive stack agree on the reactive streams mechanism underneath the covers. So RxJava 2 is reactive streams enabled. Project Reactor is designed for reactive streams out of the box. Many modern-day reactive streams are reactive data store drivers are reactive streams based. And this mechanism of flow control, we're going to get back to that, is called back pressure. And we're going to elaborate a little bit on what that really means a little bit later on. All right, this is essentially what we started with. But in the end, we're building an entire stack for modern-day reactive applications, reactive web applications in particular. So let's get right into it with a little bit of code.
A little bit. Right on. So I think we should, building upon that, we should build a sample application, something that we can use to demonstrate the different pieces in the stack. And we'll start with Reactor as the baseline. You'll see Reactor throughout the code that we're going to look at today. But remember, at the end of the day, that is just the foundation, right? We can't build a modern application without stuff above that, right? And so this is where Spring has the opportunity to really come into its own and shine, is that end-to-end sort of experience. So we're going to build a sample application. Let's build an application that manages, let's say we had a service, some sort of service on the internet, some sort of service that allowed us to manage or interact with movies, right? And in colloquial English, you could say, you could call a movie a flick, right? And the plural of flick is flicks, right? So if we had some sort of service over the net that allowed us to interact with flicks, some sort of net service that allowed us to work with flicks. And we want to have it in the spirit of what we're talking about here. As Juergen just explained, the Reactor API provides two specializations of the publisher interface in the Reactive Streams initiative. One is called a flux, and the other is called a mono. So maybe we could call our service NetFlux, right? So we'll build a very simple application. We're going to build a very simple application to manage movies on the internet, right? And we're going to just a simple demo application. We don't care all that much about it. And we're going to call this the Flux service. And in order to build this application, we're going to use Spring Boot 2.0. Now, mind you, this is still milestones, right? This is not a GA release yet. That's due end of the year, before Spring 1, hopefully. And so we're going to take advantage of early days technology here yet. But even so, there's a lot to play with, right? A lot to work with. So we're going to build an application that takes advantage of Spring support for building web applications, reactive web services. We use Lombok, which is a annotation, a compile-time annotation processor. And then we have to choose a data access technology. And you notice that if I do that, if I go to the data access tier, I can see that there's a lot of different options here. There's Reactive Redis, Reactive Cassandra, and Reactive MongoDB. And there are even other options that are even further still supported by Spring Data. But the Spring Boot project doesn't yet offer auto configurations for those yet. That will come in time. So we're left with these three choices. And we could choose any one of these for now, but I like to use MongoDB because it's very familiar. How many of you are using MongoDB? Just curious. Very curious. Okay, see, MongoDB is a fine choice for our demo because when you want to lose all your data for no apparent reason at random times, and you want to lose it reactively, there's no better technology than reactive MongoDB. So we'll use reactive MongoDB. There we go. And we're going to hit generate. And that'll give us a zip file, right? Hopefully, Wi-Fi permitting, that we can open up in our IDE. So here we are. Downloads, unzip. Flux service, go to the directory here, and I'm just going to open this up in my ID, and it doesn't really matter what ID you're using. There are very few of us who can do expert things in text editors, like Dr. Subramaniam, my hero and friend, but I'm going to use an ID. I've got IntelliJ, JetBrains, that's one fine choice. Eclipse is fine, NetBeans is fine. How many of you are using Eclipse? I'm just curious. Just curious. Good stuff. Right on. What about IntelliJ? Okay, that is... Woo. What about NetBeans? What about NetBeans? Anybody? Okay, very good. Right on.
So while we're at it, who's been using start.spring.io before?
Just curious.
Is that
right on.
Cool, very cool.
And what about Emacs? Are you here, sir? Is the Emacs guy here?
There's always one guy.
Every single conference, every single city, continent, and country that I go to, I ask that question, and it's the same human being. The same object identity. I say, who uses Emacs? And he says, I do, and then he leaves. Presumably to troll again. At any rate, we've got an application, right? We've got a very simple application. And what we're going to do is we're going to build an application that manages movies. So the first order of business is to build just that, a movie POJO, an entity that we can persist in the database using Spring Data MongoDB. So I've got the @document annotation here that signals that this is going to be persisted as a document in the MongoDB database that I've got running on my machine. I'm going to give it a primary key, a surrogate unique key there, and I'll give it a field, string title, okay? Title, okay? There we are. Now, this is Java, and if we were using Kotlin, this would be far more concise. But
we could be using Kotlin
right?
here, but
great choices out there.
Choose to stay in Java 8 and Lombok, right?
Right. So I'll use Lombok, which is a compile time annotation processor, to make short work of creating getters, setters, constructors, toString methods, etc. Right. And with that in place, I want to be able to read and write and persist and manage entities in the database. So I'm going to create a repository. And here we come to our first bit of familiar code. We're going to create a movie repository using Spring Data, but we're not going to use the familiar Mongo repository. We're going to use the reactive Mongo repository. Right. This is very similar to the regular Mongo repository, except that the return values are publishers, and the input parameters are also publishers, right? So this is a mono, it'll return 0 or 1 values. This is a flux, it'll produce 0 to n values, right? And we have that, but now we can actually save data into the database. I want to have some sample records with which to work. So we're going to provide an object that implements command line runner. Now, command line runner is a component in Spring Boot. It's an interface in Spring Boot that when Spring Boot starts up, it's going to call the run method as a callback, allowing us to do any kind of initialization work that we want to do before the traditional request response flow of the application. This is your public static void main args array, for example, right? So what I want to do is I want to create a bunch of movies, and I want to use the theme of reactivity, of functional programming. I want to use this theme to generate some names. So we're going to say flux.just, and let's go ahead and come up with some movie names, again, inspired by this theme. So one of my favorite options, one of my favorite titles is inspired by my friend Phil Webb, the co-founder of Spring Boot, Silence of the Lambdas, right? Very good, very good. And there's a popular anime, Aeon Flux, right? Or Enter the Mono Void, right? What's that movie? I'm sure some of you can tell me. There's a movie, that's a popular sci-fi movie where they have a flux capacitor. Who can yell that out? Thank you. Back to the Future. I always forget that one, right? Back to the Future. And, I'm sure that you will think of others, and if you do think of them, you should stop us right away. That is the most important part of this talk. There's nothing else. So let us know if you find them, or better yet, maybe don't do that, but just tweet it, and we'll make sure to include them in future talks. Let's see, the Fluxinator, right? There we are. Meet the Fluxes, right? Lots of different names there, right? So we've got a flux of names, movie names, right? And what I want to do is I want to take each movie name and I want to map it. I want to say that I have the title. I want to turn it into a movie. Okay, there we are. Come on, computer, do the thing. Very good. And I'm going to pass in the title. The title is title. Okay, and we're going to create a unique ID, random UUID. There we are. And then I want to take that movie and I want to persist it. So I'm going to say flat map movie, or just M, I guess, M. And I'll save it to the repository. Save M. Now, this is interesting. It gives us a response. It gives us a flux, right? Am I done? Has this actually worked? Right? Is this what's going to happen when this code runs?
It's almost, right? We specified what needs to happen, but we are not actually triggering it yet because a reactive type, a reactive streams publisher, doesn't actually do anything at all until a subscriber is being registered, and the subscriber is actually asking for elements of data to be published, to be produced. So in order to put this into action, we need to subscribe.
Right, so I'll call the subscribe method, and there's the usual suspect. There's a consumer that takes a movie. That's certainly one option, but I'm not really, I'm gonna run this code after everything has been written out, right? So the subscribe method will cause everything to be written out. If I'm interested in the emitted values, the values that are produced by the publisher, I can provide a consumer, but I don't care about those values. I just want them to be written, so that's irrelevant. I can also provide a consumer in the overloaded version that handles the exception, if there is any, a throwable, but I don't care about that. What I really want is a runnable that when the code is done, I can call, and it'll just list everything that we have here, right? So I'm going to say subscribe to all of the data. So I'm going to say print out every single record that comes back, and then confirm that we've got it in the database. So here we go. That should be something, right? Let's just run that code and see what we get. Now, it looks like it worked, but something's afoul, right? Something's amiss.
There are duplicates.
We've got duplicated data. You see, it's already persisted some earlier records from earlier incarnations of this code, of this talk. You know the expression, a broken clock strikes true twice a day? Even MongoDB will save data occasionally, right? So we've got to make sure that when we run this application, we clean up MongoDB. So this is a good chance to demonstrate a dependent call. What I want to do is to run this code, run this functionality after we've deleted all the data. So let's just streamline this just a bit here, okay? So I'm going to say movie repository.delete all, and then I'm going to say that I want to do a then many, and I'm going to pass in the publisher. And the publisher in this case is just all of this, right? So here we go. That code gets run after the code, after the publisher's run. So now we have the same basic setup as we did before, but it's just a little cleaner. So let's try that, okay? And we didn't do it the wrong way. The first cut of this code I did like this. I did delete all and then block. And I showed that to my girlfriend, and she looked at me like she looked at me like she was disappointed. Like she had made a terrible mistake and she was reconsidering things. So that wasn't the right way. This, the code is no more complex as we've done it here, but now we benefit from the fact that behind the scenes there's something that's going to call that at the appropriate time, right? Anything else to add, my friend? No?
Yeah, it looks like a fine chain to me.
Okay, very good. So now we've got data in the database, and what I want to do is I want to be able to talk to that database, right? So I want to be able to interact with that data in some way, and I could use a repository, but if I have any kind of coarser business logic, then I'm going to have a service. So I'll build a service here. I'll say that this is going to be my movie service, and this is just a string bean. It's annotated with @service, and we'll annotate with that service, and I can imagine at least 3 useful endpoints here, 3 useful services. One is a service that returns a single movie by its ID, right? So string movie ID, there we are. Okay, whoa. Okay, and I can imagine wanting to get all of the movies, right, in the Flux. So Flux movie, all, and there's this. And I can imagine wanting to show information about who's watching videos, right? Imagine if we did actually have a bazillion people logged into our service, logged into the system, streaming videos. They're watching videos, and we had the opportunity to tail the logs. In essence, we're streaming their streams, right? So I want some endpoint that gives us that information. So we could look at all of the movie events. In order to do that, I need a new entity, a new POJO, a new thing called a movie event, and that's just going to contain a movie and a date, right? When it happened. So what movie is being watched and when it's happening. And we can use Lombok to make short work of creating the constructor and all that stuff. So there's this. And we'll say public flux of movie events. And this is, of course, for a given movie, right? So here we are, return null. Now, I think the first 2 of these are pretty straightforward. This is pretty straightforward. We can inject and work with the movie repository as we've done before. And then just delegate to that, right? So add constructor parameter, and we say movie repository dot find all. Very good, not bad. Movie repository dot find by ID. No, sorry, movie repository dot find by ID. Passing in the movie ID, and then for this one, we don't actually have a bazillion people logged into the system, so I want to fake it until we can make it. We want to have an endpoint that just returns new data in perpetuity, forever and ever and ever, right? So we're going to generate 2 fluxes. We're going to have a flux.interval, and the interval is going to say, it's going to generate a call every second. What? Every second. Duration of seconds, right? So there's our first flux. It's going to be generating a new value every single interval. And the second flux is going to generate a new movie event whenever it's asked, whenever it's expected, right? So movie event, and we're going to do this by saying flux.fromStream, and I'll use the convenience method stream.generate, and just provide a new supplier object, and that supplier is going to provide a movie event when asked, and then to create the movie event, I need to pass it a movie, and we haven't gotten that reference yet, so let's worry about that in a second, right? We're gonna look it up by using this movie ID in a second here, and we need to provide the date. So let's just imagine the movie's coming in, and we've got a new date every second, right? Every second. Now, what I want to do is I want to grab a new record from the first flux every time. Or rather, a new value from the second flux every time there's a new value from the first one. I want to move in lockstep. I want to gate the production of movie events to the cadence at which I get new intervals, right? So of course, this is going to be limited to one value every second, and we can gate them by zipping them together, right? This is an operator in the reactor library. So I'm going to say zip interval and zip the movie flux, and what that gives me is a flux of tuples. And the flux of tuples has, each value that gets produced is both a long from the first one and a movie event from the second one. And I don't really care about that, the composite value. I just care about the second value, right? So I'm going to say tuple 2 get T2, right? Here we are. So there's that. And I can return that code. Now that's fairly straightforward, 3 fluxes, but I still haven't talked about how I get this, right? This is a dependent value. I can't execute this code until we've arrived at this value. So what we're going to do is we're going to just call the other thing there, and we're going to say, when I get the mono that comes back from this, the thing that has a single value, when I get that mono, I want to transform the mono into a flux. So I'm going to say flat map mini, and just return all this code. Here we are. Okay. There we go. There's our events endpoint, and we're just, it's a synthetic thing, but this gives us the ability to now build a REST API, right? And there's a few ways by which we can do this. Is there anything you want to add to this before we move on, my friend?
This is, of course, this events endpoint is sort of a little bit artificial, right? And that it generates artificial events, but it does showcase a few nice things in terms of what Reactor can do. It also there's a clear hint that there's some scheduling going on in the background, because we are instructing our pipeline to produce a signal every second, and to correlate every time we get that signal, we generate a new movie event. So in the background here, even if nothing's actually happening until the subscriber is registered, it is all prepared to be scheduled on Reactor's scheduling mechanism underneath the covers at runtime. A reactive runtime library, a reactive kernel, has a very specifically tailored scheduling mechanism underneath the covers, usually configured along the powers of the underlying hardware. So basically the number of threads matches with the number of CPU cores. And it does some really smart scheduling of the individual callbacks that we build into our processing pipelines here. And we leave it totally up to the runtime environment to make the scheduling choices for us. So we are kind of declaratively saying what we want at runtime, what we want to happen. We leave it up to the reactive kernel to make the scheduling decisions for us, and to defer execution to the best possible degree. So once a subscriber comes in, and once the subscriber is actually capable of processing it, then and only then the reactive engine will start scheduling our actual tasks.
Right on. And that we're going to pass these return values to the next level up anyway. So we don't want them to start processing until that is ready to do it. And that next level up in this case is going to be a web tier, right? And so there's a couple of options that we're going to look at. I think we should ever so briefly take a look at the REST controller style. Maybe just do the abbreviated version.
So we have a nice repository. We decided to do a service layer. We would not have to have a service layer necessarily, but it fits our purposes here. We need a web endpoint now, a web controller.
And we can as a first cut, we can look at something that should seem altogether very familiar if you've ever used Spring MVC. This is a net new runtime inside of Spring 5. It's called Spring WebFlux, and it looks very familiar. It's very familiar. It's very firm ground for anybody who's coming from Spring MVC. But there are some concessions to the fact that ultimately this is a reactive runtime, not a traditional servlet API.
This is the design is intentionally analogous to Spring MVC. It provides a degree of familiarity, reuses the general handler method model, flexible argument signatures, flexible return types. It reuses the actual annotations. So what we're seeing here is REST controller, the mappings, those are all the same, the literally same, identically same annotations that are also being used in Spring MVC. But ultimately, we're building web endpoints for the reactive web framework that we call Spring WebFlux in Spring Framework 5. This is its own web framework with its own limitations and its own semantics. It runs on a reactive engine underneath the covers, on our reactive HTTP abstraction, can run on Netty, which it does here, underneath the covers. It can also be adapted to a Servlet 3.1 container. We actually have dedicated support for Tomcat, for Chetty, for Undertow, not only for their asynchronous I/O mechanisms, but also for their data buffer capabilities. So we can actually build a reactive web stack, not only with Netty, but also, for example, with Tomcat and Chetty. But we're not even dealing with this right now. Let's just assume this is running in a reactive web stack at runtime. The main difference here to Spring MVC is the purpose of the handler method. What is the handler method required to do here? It isn't being invoked within a servlet request thread, and it doesn't own the servlet request and doesn't generate the servlet response. It has a different purpose. It gets invoked, dispatched to at runtime if a corresponding request comes in that matches its mapping. And then the runtime is going to ask for a reactive streams publisher, basically being able to produce a response for the given request. And that's literally what the handler methods return, a reactive streams publisher, a Flux or a Mono. Once the runtime environment decides and figures out that it can actually write response elements out to the HTTP response stream back to the client, then it registers a subscriber, and the subscriber is going to start taking elements from our publisher. So it's a very lazy mechanism. If for any reason the response stream gets canceled, if for any reason there's congestion in the network, the publisher is not actually going to produce anything. That's our flow control coming in again. So we have all the powers of a reactive runtime processing stack with a familiar programming model.
Right, and that's a feature. So let's take a look at that in action. I've taken the liberty to code this up. I think that'll work. We've got an endpoint for the ID and for the events and for the all method. Now there's a mistake in this code, but I want you to, by way of illustration, see what it is. So there's my movies endpoint I've just called, and we get back, let's just pick any particular ID there, and we can say now paste, and that gives me that one record. And now let's call the events endpoint, right? That events endpoint is supposed to just give me everything forever, right? Well, curl isn't expecting that. Curl is a pretty simple client. It doesn't expect to load, JSON that'll last till the end of time, till heat death, right? It's expecting to be able to get to the end of the buffer and then return it to the client and represent it in the console here. It's expecting that because we're calling an HTTP application JSON encoded sort of endpoint. Instead, we need to give it a clue that the data that we're sending back is of a type that may never cessate, right? So we're going to use the server send event protocol here, right? This is a different kind of way of sending data back to the client. And the clients are going to be, they're not expecting to be able to just wait for the response. It's a server sent push, basically. So I can say, given the movies, and I can ask for an ID here. So here's my ID. Okay, copy. We paste that in. Good, no problem. Get the events. Hey, there you go. Very good. So we've now got the data framing. This is going to go on and on and on forever and ever and ever and ever. So long as there are stars in the sky.
Mm-hmm. Movies being watched.
Movies being
by
watched.
someone in the world.
Bugs in your code, just forever and ever and ever. So we've got that, right? We got the service and event thing. That's working just fine. And this is certainly nice. It's a nice approach. But let's take a look at a different approach, right? One that's inspired by some of the other programming models in the ecosystem. If you've ever used Sinatra in the Rails world, or in the Ruby world rather, then that'll feel very familiar. Spark Java and Ratpack and the JVM ecosystem have a similar programming model. Basically, this is called the functional reactive approach. And it's if you haven't used this before, it'll feel a little unfamiliar, but it's very, very cool. The way it works is we create a route function, and we describe in that route function the request predicate, either e.g. that we want to accept requests that come into movies, and then we give it a handler function, a function that's supposed to handle the request. And of course, you can see that, perhaps you can see that, yeah, it's great.
Just about.
It's great. You can see that this is amenable to being converted into a functional interface, or to a lambda, because it is a functional interface. So I can actually extract this functionality out into a separate component, into a separate method, and then do the work there. So I could, for convenience, I like to create a handler, right? Movie handler. And this is just a component that'll have methods that can be coerced into this lambda type. So here's a movie handler for all methods. Here's another one for, or all movies rather. Here's another one for by ID. And here's another one for the events. And we're just going to use this handler instead of doing the code in line. You could do it in line, but it might get a little hairy if you have too much code in one place. And we have a small screen real estate here on the stage, so we'll make it a little easier for us to focus. Okay, so there's all of them, right? We're just going to use a method reference there. And we can say and route request predicates dot get movies movie ID and pass into by ID, and then do it again for the events, yeah? So events, movies, movie ID, events, handler, events. Very good. So there's our route configuration. And of course, this is a little tedious, but you can get rid of that by using static imports. So add on demand static imports for that. And for this one, or not. Come on, computer. We'll leave that alone. So anyway, now let's implement this code. And this handler requires us to use the service, which we created earlier. That service is what makes it so easy for us to switch out implementations. Normally, you might skip that step, right? Because it's not all that much business logic. You could just go directly to the handling in the code itself for the handler. So
for our purposes, we're reusing the exact same reactively enabled movie service that we built before, that our annotation-based controller was using. But we're now building a differently styled web endpoint, tapping into the same reactive service operation.
So you notice that we're creating a response dynamically here, and we're sending back, as a result, the publisher. And the publisher, of course, is expecting, in this case, a movie ID, which is part of the mapping definition. So we can say, I want the path variable for the variable called movie ID, and we can pass that in here, movie ID. And here, again, we tell the publisher what kind of data we're sending back. Again, in the Spring MVC style handler methods, the runtime, the framework, can infer that by looking at the return value. It's a flux of type movie. But we need to give our runtime an opportunity to send data back and to figure out when to sort of close a frame, a packet, payload. Basically, we're doing data framing. We're given a clue about when to do that, right? If we had reified generics, then we wouldn't need that.
If you use the Kotlin variant of this routing DSL, it's actually streamlined in that respect because the Kotlin language has reified generics. So for everything we're doing here, we also ship Kotlin extensions, in particular for the routing DSL, that make up for a really idiomatic configuration style, endpoint definition style in Kotlin. But for our purposes, let's stay with Java 8 here.
Go with what we know. Here we go.
So we re-implemented the same endpoints now in different implementation style. So we're just double checking. Is it still doing?
I forgot the content type again. So.
Oh yeah.
Events,
body. Our standard mistake.
Content type, media type, text event stream.
Otherwise, curl once again doesn't know that the stream's never ending.
Okay, movies. And grab this ID. Paste, grab the events.
Yes, please.
Good, very good. So there we go. We've got our events. We've implemented it using Spring MVC style controller methods, as well as the functional reactive endpoints.
Right. Maybe a few words on the design implication. Can we go back to the source code just for a moment?
Yes, sir.
So we literally re-implemented the same endpoints with the same behavior in a different style. But where's the trade-off here? And there are quite a few. The annotation-based model has its clear strengths. It has declarative mappings, it has flexible argument signatures, flexible return types. None of this is present here. This is essentially a programmatic, functionally styled routing DSL with router functions and pointing to handler functions, making the best possible use of Java 8 language features and there I add Kotlin language features if you're using Kotlin, but Java 8 language features here. So you could use inline Lambda expressions for the handler function, or you can point to a factored out delegate method, as we're doing here, which we actually recommend. But you can still use Java 8 language features, a method reference. In the Java 8 method reference model, of course, there is a target functional interface that we're binding to. So all of our endpoint signatures have to comply with the signature of that functional interface. And that's handler function. Handler function has a server request going in, a mono-of server response going out. So we are tied to that. All of our methods have to programmatically interact with a server request, and they have to build a server response. So it comes with a different set of trade-offs. But it is entirely programmatic. There's no reflective dispatching. There's no annotation resolution here. So it is extremely efficient in that sense. It is also, of course, a style very familiar from functional composition models out there in the wild, right? So it's not it's a style where we've been inspired by certain industry trends towards functional composition APIs.
Absolutely.
So it's a kind of nice balance. It's two choices that we're offering for implementing reactive web endpoints. Your choice of whatever appeals most to you, right? For a smaller set, maybe a microservice model, 3, 4, 5 endpoints, the routing DSL is super sweet, super nice, fits on a single page, even with inline handler functions maybe, with Lambda expressions inlined. Whereas for a larger web surface with a decomposed model, decomposed endpoints, the annotation-based model, of course, has its strengths very clearly, right? So it's a choice that we're offering between those two, but as we see here, you can implement the exact same behavior in both models, and you're using the same runtime infrastructure underneath. It's the same WebFlux framework, the same reactive HTTP abstraction, our same handling of the Netty engine, the same use of the Reactor kernel. It's all the same infrastructure, the same codecs for, like in this case, the JSON translation. So the same reactively enabled codecs. All of this is the same common infrastructure underneath, just two different ways of tapping into that stack.
Right on, exactly. So two great choices. Choose the one that you prefer. They're great. They work fine either way. Now, we've got an application. We've built an HTTP service that's talking to a database, and everything so far has been reactive, right? We're not blocking it at any level in the application. So the next logical step at this point, usually for me, is I start thinking about security, right? This is going to be an application that I want to deploy, hopefully, and in that world, security is an important factor. So I want to introduce security into this application, and this is an important consideration because the last thing that we want, having gone to all these lengths to introduce reactivity at every layer, from the web tier all the way down to the database tier and then back in the programming model, is to then block or bottleneck at some sort of thread local in this, holding your security context, your authenticated principal. So thankfully, Spring Security 5 is on the horizon, and it has built upon Spring 5 and all of the reactive APIs that we have therein, and we can use that in our application here. So let's go ahead and just secure this service very, very quickly. Now, there is no, right now, there will be soon, but right now, at the moment, I have to manually bring in dependencies for Spring Security, and I have to admit, that wasn't easy. It took me a long time to remember how to do that, the hard way, like this. I'm used to just clicking checkboxes at this point. So, config and WebFlux, exactly. This is the Spring Security WebFlux integration. And those are our three dependencies that we need to be able to make this work. And all we want to do, just for our simple example, is we want to have a security configuration. So this is a configuration class that describes the security configuration for this application. And it's going to activate the WebFlux security by saying @enable WebFlux security, which I think, pretty straightforward. We're going to define it. We need to tell Spring Security how to do authentication, right? It needs to answer the question, given a request, who's making the request? And so we can define a bean of type user details repository, right? And this is just an object that it's going to talk to answer the question, who's making the request. In this case, we'll just give it a hard-coded list of users, right? In a map. It's an in-memory map. You can use whatever you want in a more sophisticated Spring Security application, but for our purposes, this will be fine. So we're going to say user.with username jlong.roles will just be user. Password will be password. And .build, right? There's this, and we'll do the same thing again for Josh, and then this is Juergen. Okay, whoa. Okay, Josh, Juergen, J. Hoeller, and then of course he's also an admin because he's the boss.
I really want
right?
to be an admin here, please. Oh yeah.
So there we go. There's Josh and Juergen, and these are, for authentication purposes, we could do authorization. We could make a decision based on the role, whether this person should be allowed to make a request or not. But for now, the default behavior is that when you have a user details repository and nothing else configured, it'll let authenticated requests through and it'll reject the rest. So let's go ahead and give that a go once we've got that started and running. Now, we'll say movies. And that didn't work, right? That's by design. So if you look at the output there,
unauthorized.
401 unauthorized. So now we say J. Hoeller password. Okay, there we are. There's our response. That worked as we expected. Now let's prove the negative. Let's get rid of let's tamper with a password here just to make sure we're not seeing a fluke. There we go. 401 unauthorized again. So that's certainly very useful. Now we've got a service. We've got a service that's talking to a database. It's reactively secured. There's a web tier and there's data access layer. We should build a client.
Yeah. What if we had a microservice architecture and some other service of ours also implemented in Java with Spring Boot wants to call our FlixFlux service?
Imagine. So that's what we want, right? So let's go ahead and build a FlixFlux client, Wi-Fi permitting. Oh, good stuff. Okay. CD downloads, unzip, FluxFlix client.zip, CD FluxFlix client, and we'll open up this project in our IDE. And the work here is fairly simple. All we need to do is to build an application that talks to the HTTP service using a web client, using a client that speaks HTTP. And at first blush, this might seem like a use case for the REST template. And the REST template in Spring has definitely served us well, but it is a blocking client by default, right?
REST template is a pretty traditionally structured blocking invocation API, like JDBC template, like JDBC itself and JPA itself, right? It is. We could be using it for a simply structured client. It talks to a target HTTP service, obviously that can be modeled with any HTTP client. But for our purposes, maybe a larger microservice-oriented architecture, it really brings a lot of benefits into the entire architecture to reactively interact between the services as well. In particular for HTTP, going over the network, there's a high chance that it is actually blocking at some point, and we might be processing the data further on afterwards. We might build a larger interaction chain, a larger processing chain, but for our purposes, we keep it rather straightforward, right?
Right, so now we've got the web client. The web client here has been configured to have a base URL, HTTP localhost 8080 movies, and we've taken into account the fact that we've got authentication to care for here. So I've configured a HTTP basic aware filter, authentication filter, exchange filter, and now I'm going to use that newly configured web client in my command line runner here. So what I want to do is I want to make a call to the root URL, so quote, and get the response back, and then say body to flux. And I'm going to do something that you should never ever do. And I want you to just keep this in mind. You should never ever do this, not even when you're all by yourself, all alone at home, and no one is looking. I'm going to copy and paste code. You should not do that, right? I'm going to get rid of that ID.
Just artificially delete a few annotations.
Right, yeah. And I don't need the interface. And there we go. There's my two JSON DTO sort of entities there, things. And I can use those just to coerce the JSON that we get back into objects that we can work with. So we're going to say, give me back the JSON that comes back as a flux of movie. And then what I want to do is I want to filter. I want to say for each movie that I see, if the title equals ignore case A on flux, then let's subscribe to it. Or actually, it's even better. Let's say flat map. And what we're going to do is we're going to turn that into another collection, right? So we're going to say, for this movie that we found, the one that implements what we want, let's say client.get.uri movie ID, movies, passing in the movie ID, so m.getID, and then we're going to say retrieve body to flux movie event. Oh, sorry, this is events, thank you.
Yeah, we're talking to our service and event endpoint there.
Right.
Trying to get the movie events again.
And then that, I think, will do it, right? So now, here, we can return this, and .subscribe. So all I'm going to do is I'm going to print out what comes back as a result of this processing.
Once again, we want to see what we are getting here.
Get rid of that. Don't need this. Don't need that. There we are. A little bit cleaner. There we are. So there's our code. And we're just going to print out everything that comes back. And I can clean this code till the cows come home.
We still need to change the application properties.
Oh, thank you. Yes.
We have two services running on the same machine here. So both of them have an HTTP server by default. So they need to run on different ports. All right.
Okay. Go back here. Let's see if that works. Hey, there we go. Look at that, huh?
There they're coming.
So there's our secured interactions with the HTTP service. We're using service-end events. This is just one kind of protocol. Some people ask me, is this a replacement for messaging or something like that? No, I'm not trying to, that's definitely not the intent here. I just want you to appreciate that there's other options here for talking to services. Okay, so what have we looked at today, my friend?
This has been a little bit of a dive into what we're providing here. There's much more to discover, of course. But just to reiterate what we've been showing here, in the Spring Boot 2 stack, where Spring Framework 5 and Spring Security 5 and all those pieces come in here, we are providing a basically complete reactive story, both for the modeling of server-side HTTP endpoints, the modeling of client-side endpoints. We have first-class support for several reactive data stores in the Spring Data K initiative. All of those pieces are part of a larger story and form a really nice, comprehensive overall stack. So I'm going to elaborate a little bit more on Spring Framework 5.0, the roadmap, and other themes other than the reactive story tomorrow in my Spring Framework 5 themes and trends talk tomorrow afternoon. And we have a BOF at 19:30, I think in room 2, where we can also have any discussion you guys want to have with us.
It's going to be so fun.
Yeah. So just to a few key points summarized. The reactive web stack that we're building is based on Project Reactor. Project Reactor is kind of our choice for a reactive kernel. Project Reactor is, of course, very much aligned with functional API styles out there. So if this feels familiar to you, if the operations feel familiar from the Java 8 collection stream API or from RxJava, that's no coincidence. There's a strong inspiration and a close collaboration there. In particular, between RxJava 2 and Reactor, there's been some really fine collaboration. David Karnock, the RxJava 2 project lead, is a committer, a contributor to Project Reactor 3. So there's been really tight alignment between those two, because in the end, Project Reactor is a more focused arrangement. RxJava is used on Android a lot. It's Java 6 compatible still. In Project Reactor, we could really take the opportunity to build a modern 2017 Java 8-based server-oriented reactive kernel. So this is the foundation, and the API with Flux and Mono that you've been seeing here, those are the two essential entry points into the Reactor API that are showing very strongly also in Spring Framework 5. So if you're looking at our API design, Flux and Mono are really key pieces in modeling the reactive processing pipelines that we're exposing and that you're building and providing to our framework. All right, and in terms of the decisions between, do you want to build this kind of web stack over a server-based web stack, that's a topic for another talk, right? We are providing choices here. So we are not actually saying that the reactive web stack is very clearly the only way to go about certain things. It has clear strengths. I mean, the server-sent event endpoint is a great example. It's so natural to implement a server-sent event endpoint in the reactive model. It's a little more awkward to do this in the servlet model, where you have to get out of the servlet thread and kind of... So some things are more natural to model in the reactive world, for sure. But there may be strong reasons why the servlet-based endpoint model is your preferred choice. Number one reason, blocking data store APIs. If you want to keep using JDBC, JPA, thread-bound transactions, by all means, you're going to have an easier ride in an efficient servlet-based stack with Spring MVC, the Spring REST endpoint model on top. So the way I'm seeing this is from the data store up, really. So to put this sweetly and to wrap this up for this session, if you have a data store, if you're able to choose a data store or have already chosen a data store with reactive capabilities and a nice modern reactive driver, by all means try to expose this reactive interaction power through to the web framework. So if you have a reactive data store like MongoDB, Redis, Cassandra, Couchbase, all of them have reactive drivers, it really suggests itself to build a reactive web endpoint model, a WebFlux-based web stack on top. All right, well.
On that note, there is some encouraging news. Last year at Java 1, Oracle alluded to the idea that they want a JDBC, a reactive JDBC story, right? Mm-hmm. And I have full confidence with their, crack team of engineers. This will be done in the next decade, so it'll be ready for you if you need it, right? That'll be there eventually.
There is an asynchronous Postgres driver in the works. I'm not actually sure what the status there really is, but there are initiatives. There are going to be more reactively enabled data stores in the near future for sure. But this is a critical piece. A reactive interaction model, a reactive processing model, makes most sense if it's reactive from the bottom to the top, right? If you expose the reactive power from the data store at the bottom to the web endpoints on top. And this is the primary purpose of our WebFlux framework, of our reactive web endpoint model, is to be able to expose that power if you can.
All right.
All right, so much for the purposes of this talk. We're happy to take questions here if you come up. We have the BOF in an hour.
Yeah.
So by all means, if you want to have a more extensive conversation, come to the BOF, please. Bring the drinks if you find any out there at the party. And if you're interested in more of the strategic positioning of Spring Framework 5 in other themes other than reactive in Spring Framework 5, and in the roadmap in particular, please come to my Spring Framework 5 Themes and Trends talk tomorrow.
Thank you.
Thanks for your attention.
Dziękuję. Thank you so much.